In this video, we're going to talk about memory. What are the different types of memory that you're going to see in a computer? Okay, so all about how we store information as we're using it. Now, in the last video, we talked about hard drives, and that is the files and the work products that we create. We're not talking so much about that as we're talking about what the computer now is using as its brain, as it does its thinking, okay? Okay, the first one we're going to talk about, I can't imagine you haven't heard the term RAM being used. But what you need to know is that it stands for Random Access Memory. And this is what we call volatile memory, which means if it loses power, it all goes away, okay? And it is directly read from wherever it is in RAM. Okay, it doesn't have to go do some sort of a table lookup. It can be read directly from its location in memory. So there is a memory address for all of the information in RAM. Okay, RAM used to be called SRAM or static RAM, and that used what was called flip-flop circuitry. Now we're not going to get into the physics of flip-flops. But basically, this was switches on, switches off, switches on, switches off type memory, okay? The newer RAM is called dynamic RAM or DRAM, and it uses a single transistor and a capacitor for each bit to represent whether it's a 1 or a 0. And that's all you need to know for this course, okay? It's using MOS or metal oxide semiconductor circuitry of a transistor and a capacitor, okay? So when you hear DRAM, we're not talking about a DRAM, we're talking about a DRAM, which is dynamic RAM, which uses the MOS technology as opposed to the older flip-flop memory, okay? Now RAM, like we've said, when the power goes off to your computer, it's gone. Your RAM is effectively, you can call it erased, but it really just is lost. And then when your computer comes back on, more information can be stored at RAM. And the thing I want you to really understand is that you can read it directly. Okay, now on circuit boards, and here's an example. On circuit boards, a lot of times we need a chip that holds a program that is used to help the motherboard circuitry do things. For example, we talk about the BIOS, okay? The program that starts your computer, all right? Those types of circuitry need to be burned into chips, okay? So that it's always there. And if I'm going to create a device that needs that program on either the motherboard or the circuit board that I'm using, I don't want to have to keep loading that from some other type of drive. I want it burned into a chip that's plugged into the board, so when you turn on whatever the device is, whether it's a camera, a video camera, my pool control unit that I'm in the middle of repairing, I'll show you that in the next video, you burn the program into a chip so that the same 1s and 0 pattern that make the program of instructions that you need to be executed by the processor is permanently on the chip itself, okay? And this is called ROM, or read-only memory. It is created in a factory where the program is burned onto the chip. The program circuitry is permanent on the chip. It's done at the factory, and all you can do is read those memory addresses. So you can read the program from memory, and so you can create a program that works on a chip, create your circuit board for whatever it is you're powering and controlling, and then you can just plug these things into all of them in the factory, and that program is always there as part of that motherboard. And if you look at a motherboard, you're going to see ROM chips all over the board, okay, doing various things. Running the South Bridge is a good example of where you might see that. Okay, it's non-volatile because it's burned onto the chip, okay? So it's not going to lose memory, and you can't change it once you've burned it at the manufacturer. It's read-only memory, okay? And the BIOS on older motherboards was basically a burned ROM chip. And as they started modernizing PCs, they realized And we kind of need a way to update this, and that's where we get to some of the other things we're going to talk about. So think of ROM as hardwired. It's there, it is what it is, and you're not going to change it. You want to fix it, you need a new chip into the motherboard, and a lot of times you just need a new motherboard or a new circuit board. Okay, so as they were doing ROM in its infancy, there's always been the Bill Gates and the Steve Jobses who want to create their own computers. And so they wanted a way that you could buy what was called a blank ROM chip, and where you could put your own program on it. You didn't have to go involve a factory or own a factory or go through all that. But as someone in my garage, I want to put a particular program on a chip, and then I want to put it on a motherboard and be able to use it. Okay? So they created circuit boards that supported sockets into which you could plug a ROM chip, or a PROM chip, excuse me. And PROM is programmable read-only memory. So you would buy what was called a blank, and you had a writer, or we call them burners, and you could plug that into the burner. You could load your program into it, and it would literally write it to the chip, and you had one shot at it. Okay? Then you would take it out, and you could insert the prongs from this chip into the socket, and the socket was obviously welded to the motherboard, and you could create your own PROMs. Okay? So you would buy blanks and then burn them into with a programmer or a burner, and then you could use them. If you did it wrong, or your program had a bug in it that you later found, you'd have to take that out, throw it away, put a new blank in, write the new program, and then plug it in. But that was a big deal. That was a big jump in this technology, so that you could literally, in your own basement, build ROM chips, okay, if you needed to, for whatever your project was. All right, so now they said, well, we're burning a lot of blanks. We don't want to have to keep buying these blanks. They're not that cheap. And we want to be able to use a particular one over and over again. And if you think about it, it's really kind of a normal extension to that type of growth and thinking. So they came out with what was called an EPROM chip, erasable, programmable read-only memory. And by the way, all of these, with the exception of RAM, are non-volatile. So when I turn the power off, it stays, right? It's kind of burned onto the chip, but now we want to make a jump and make it erasable. Okay, and the first one they came out with was an EPROM, which could be reprogrammed with exposure to strong ultraviolet lights. They used what was called a mercury vapor lamp. Okay, and you could tell it because it had this quartz window in it, and that is where you would expose the light to it. Excuse me, and it would literally wipe the chip. So now you could buy one of these, and if you messed up the program or updated your program, you could literally expose it to the ultraviolet light and then basically rewrite it. You could reprogram it and then put it back in the circuit. Okay? It was used on microcontrollers, and it was definitely before the next one we're going to talk about. It was a little bit process intensive. You had to make sure you had a good erase and program it, and they could be touchy at times, but basically these worked, and it was a big jump. They weren't around that long because this type of technology started accelerating, and eventually they came to what was called EEPROM. Now, EEPROM is electrically erasable as opposed to the strong ultraviolet light, and the process of doing that, you could literally send an electric signal to the chip that basically flashed everything from it. Now, this is still non-volatile, so it doesn't lose the program that's on it when you turn the computer off. And what I want you to think about is your cell phone, or your iPad, or your Surface. Okay, things that come with firmware, right, which is in some cases the actual operating system of the phone or the device. Okay, and Apple or whoever manufactures it will say, hey, we've got an update, and a lot of times you'll hear them say, it's not as much anymore, but it was like, make sure it's plugged in, make sure you're not using it, or it's got a full battery charge, and it won't even start the process until it downloaded the update onto the hard drive of the system, and then it would begin the update process. And the reason it's doing that is the core of whatever your device is, like your phone, that's the program that runs your phone. So if you interrupt that process and it doesn't do a good right, you just bricked your phone, and now you're back at the Verizon or the AT&T store trying to get it fixed, and they have to rewrite the chip with some of the special equipment they have at a repair center. So EEPROM is used in the BIOS, the UEFI systems now, to update your system. And when you do an update system, what you're doing is electrically erasing and reprogramming those devices. They use floating gate transistors, which means there's basically special signals sent to the chip to say, erase this memory, okay? And then it's going to basically redo it. Now, there's a little bit of difference between EEPROM and flash memory, but what I want you to know for this course is that flash memory is effectively electrically erasable, programmable, read-only memory. It's kind of a newer version of it. It comes out of EEPROM. There are still a lot of EEPROMs in the world. Flash memory, however, is basically a form of EEPROM. Okay? So that's really what I want you to know for this course at this level. And now hopefully you have a little bit of an idea of why you'll see those warnings, and why they want you to have a full charge on your phone before it updates, and it'll lock you out of the phone. And the new updates I've seen, it will literally, they've separated the steps of downloading the software to make sure it's completely on the system. They run through some checks to make sure it's got all of the update and that you've got room and memory and power before it will even start. So the software that actually does that process to replace that firmware has gotten a lot better as the programming has gotten better, in addition to the technology and the hardware. So that's all we need to talk about for memory. The next thing we're going to talk about is monitors. That's going to be another easy one like hard drives, but that's what we'll do on the other side. So I'll see you there.